Nobody at any space agency is going to put it quite this bluntly. But if humanity genuinely intends to live beyond Earth, on Mars, on years-long missions, or in permanent off-world settlements, eventually we have to solve sex and reproduction in space. Not as a punchline, as biology. Because sexual function, intimacy, fertility, conception, pregnancy, and human development are not side issues for a species that wants to become multi-planetary. They are requirements. And right now, we understand surprisingly little about how any of them work once you remove the environment the human body evolved in. The moment a spacecraft reaches microgravity, your body begins to change. Not metaphorically, physically. On Earth, gravity constantly pulls blood and other fluids toward your lower body. In microgravity, that gradient largely disappears. Within hours, fluids begin shifting upward toward the chest and head. Your face can look slightly swollen. Your nose can feel congested. Blood volume and cardiovascular function begin adapting to an environment in which the heart no longer has to pump against gravity in the same way. And that raises a question researchers still cannot answer directly. What happens to sexual arousal? Erections and genital engorgement depend heavily on blood flow, vascular tone, pressure regulation, and the nervous system. Those same cardiovascular systems are adapting dramatically in microgravity. That does not mean sexual function necessarily fails in space. We simply do not have direct human data showing exactly what happens. And that distinction matters, because sex in space is actually several different scientific problems hiding inside one provocative phrase. Can humans experience normal sexual arousal in microgravity? Can two people physically maintain intimate contact? Can fertilization occur normally? And even if conception succeeds, can an embryo, fetus, and eventually a child develop normally somewhere other than Earth? We have pieces of those answers. We do not have the whole picture. Then there is the physics. Newton does not make sex impossible in microgravity. He makes it an engineering problem. Every action produces an equal and opposite reaction. On Earth, gravity presses your body into a bed, floor, chair, or other surface. Friction and body weight provide stability almost automatically. In free fall, that support disappears. Push against another person and both bodies respond. Movement has to be stabilized somehow, using restraints, handholds, surfaces, or some other method of anchoring. The problem is not that two people would instantly fly across a spacecraft. The problem is that something effortless under gravity becomes mechanically complicated without it. And despite decades of human spaceflight, nobody has published a direct scientific study of human sexual response during spaceflight. That is an extraordinary research gap. Space agencies have studied parts of the reproductive system. Human sperm has been examined aboard the International Space Station. Researchers have studied ovarian cells, reproductive tissues, animal fertility, embryos, and developmental biology under altered gravity. So it would be wrong to say that space agencies are completely ignoring reproduction. They are not. The deeper problem is that we are studying the pieces much faster than we are studying the complete human system. Sexual function, intimacy, fertility, conception, pregnancy, childbirth, development. And what happens when all of those processes occur during months or years away from Earth? Animal experiments show why the uncertainty remains so large. Some studies using simulated microgravity have found changes in sperm behavior, fertilization, or early development. Other experiments have produced much more reassuring results. Mouse embryos have even developed aboard the International Space Station to the blastocyst stage without obvious catastrophic developmental failure. That is important. Because the evidence does not tell us that reproduction simply stops working in space. It tells us something much more uncomfortable. We do not yet know where the limits are, and microgravity may not even be the most serious problem. Radiation might be. The International Space Station still orbits inside much of Earth's magnetic protection. A spacecraft traveling to Mars would not. Once a crew leaves low Earth orbit and moves into deep space, astronauts face a radiation environment dominated by galactic cosmic rays and occasional solar particle events. Spacecraft shielding helps, but it cannot eliminate the problem. Depending on mission duration, trajectory, solar activity, and shielding, a Mars crew could accumulate radiation doses far beyond the annual occupational limits normally accepted for radiation workers on Earth. And reproductive biology introduces a particularly unsettling dimension. Sperm-producing tissue and ovaries can be sensitive to radiation. Radiation can damage DNA, disrupt reproductive function, and potentially reduce fertility. Damage to reproductive cells also raises another question. Could radiation exposure before or during conception increase the risk of genetic damage being passed into a pregnancy? We do not know exactly how large that risk would be for humans on a real Mars mission. And that uncertainty becomes even more serious when you move from conception to pregnancy. Suppose fertilization works. Suppose an embryo implants successfully. Then what? Every human pregnancy in history has developed under approximately 1 Earth gravity. Mars provides only about 38% of that. The Moon provides about 16%. Microgravity provides effectively none. We do not know whether 38% of Earth's gravity is enough for normal human fetal development. We do not know whether there is a minimum gravity threshold below which bones, muscles, the cardiovascular system, the vestibular system, or the brain develop differently. We do not know whether a child gestated on Mars could later function normally in Earth's gravity. And we do not know whether the most dangerous period is conception, implantation, early embryonic development, late pregnancy, birth, childhood, or all of them. That is the scientific problem. But the body is only half of it. A Mars mission is also a psychological experiment involving a tiny number of people trapped together farther from civilization than any humans have ever been. A typical transit could take roughly 7 months each way. Depending on mission architecture, the crew could then spend well over a year on the Martian surface before returning. The total mission might approach 3 years. The same small group of people, the same habitat, the same work, the same conflicts. Every day. There is no going outside without a spacesuit. There is no going home after an argument. There is no changing teams, and there is no real-time support from Earth. At maximum separation, a radio message between Earth and Mars can take roughly 22 minutes to travel one way. That means a simple question and answer exchange can approach 45 minutes even before anyone spends time thinking about the response. Real-time counseling from Earth is impossible. The crew has to solve interpersonal problems largely on its own. And we already know from isolation research, analog missions, Antarctic stations, submarines, and spaceflight itself that confinement changes human behavior. Stress accumulates. Privacy becomes scarce. Personalities clash. Friendships deepen. Attraction can happen. Relationships can form. And relationships can end. None of that makes astronauts unprofessional. It makes them human. That is precisely why ignoring the possibility would be poor mission planning. Imagine 2 members of a 6-person Mars crew becoming romantic partners. That relationship may provide emotional support and improve their well-being. But it could also change group dynamics. Other crew members might perceive favoritism. A couple might begin operating socially as a unit inside a team that depends on collective trust. Now imagine the relationship collapses halfway to Mars. The former partners do not go home. They do not switch departments. They keep living meters apart. They keep working together. They may still depend on each other during emergencies where hesitation can kill someone. Publicly available spaceflight guidance says a great deal about professionalism, teamwork, behavioral health, and conflict management. It says far less about how crews should handle sexual or romantic relationships during multi-year missions. That gap becomes harder to ignore as missions get longer and crews eventually get larger. Because once humans stop merely visiting space and start living there, intimacy stops being an edge case. It becomes part of settlement design. Habitats may eventually need to provide genuine privacy rather than just individual sleeping compartments. Medical systems may need reproductive health capabilities. Crew selection may have to consider relationship dynamics. Mission planners may need explicit policies around consent, contraception, pregnancy, power imbalances, and relationships between people who may also occupy different positions in a command hierarchy. These are not arguments for encouraging sex during missions. They are arguments for accepting that human beings remain human beings when you put them inside spacecraft. And the issue becomes even larger when private spaceflight enters the picture. Government space agencies traditionally send small, heavily selected professional crews. Future commercial stations and large transport vehicles could carry significantly more people. As crew sizes increase and missions stretch from months into years, romantic and sexual relationships become something mission planners will increasingly have to account for rather than dismiss as an unlikely complication. Then eventually comes the question that makes everything else look small. Children. If humanity genuinely becomes a permanent multi-planetary species, someone will eventually attempt a pregnancy away from Earth. Maybe not on the first Mars mission, maybe not on the 10th. But a civilization cannot become permanently self-sustaining on another planet if every generation has to be imported from Earth. At some point, reproduction becomes unavoidable. And when that moment arrives, the questions become enormous. Can conception occur safely after prolonged radiation exposure? Can a placenta develop normally under partial gravity? Can a fetal heart form and function normally? Can bones mineralize correctly? Can the vestibular system develop without one Earth gravity? What happens during childbirth in 38% gravity? What happens if there is hemorrhage? What happens if an emergency C-section becomes necessary? What happens if the newborn needs intensive care? What happens when the nearest major hospital is millions of miles away and the medical advice from Earth arrives with a 20-minute delay? And perhaps the strangest question of all, what happens when that child grows up? A person born and raised on Mars may develop a body adapted to Martian gravity. Their bones, their muscles, their cardiovascular system, their balance, their entire developmental biology. Could that person safely visit Earth? Would one Earth gravity feel merely uncomfortable or physically dangerous? Nobody knows. And that is why the real story here is not that space agencies have done nothing. They have studied sperm. They have studied eggs and reproductive tissue. They have studied embryos. They have studied radiation. They have studied isolation and crew psychology. They are building pieces of the answer. But humanity is simultaneously designing missions that may force all of those pieces together before we completely understand how they interact. So here is the question. Would you volunteer for a multi-year Mars mission knowing that the effects on your long-term reproductive health are still not fully understood? Yes or no? Because that question is going to stop being hypothetical much sooner than most people realize. We are building larger spacecraft. We are planning longer missions. We are studying Mars habitats. We are developing life support systems intended to keep humans alive farther from Earth than ever before. But keeping a human alive for 3 years and building a civilization that can reproduce for 300 years are completely different engineering problems. The first requires a spacecraft. The second requires understanding the entire human life cycle outside the environment in which it evolved. Sexual function, fertility, pregnancy, birth, childhood, relationships, psychology, radiation, gravity. None of these can remain permanent blind spots if humans genuinely intend to settle another world. The universe does not negotiate around gaps in our planning, and nature does not care whether a subject makes mission planners uncomfortable. Sex in space is not the embarrassing footnote to the Mars program. It may be one of the most important chapters we have not written yet.